Nope, not that one. Let's go here. All right. So in the second part of this 9.1, section 9.1, today's video, we're going to talk about quadratic graphs and parabolas again, but we're going to take a look at what happens to the shape of the graph as you change what's called the C value, which we'll discuss and take a look at. In the first video, we looked at what happens if you change the A value, which is the number in front of x squared. Now we're going to see what happens if you change the C value. And you might say, what about B in between? And that'll be for another video because that is a little bit more involved. As a brief little warm up, just to remind ourselves, we're going to look and compare, match each equation that's listed down here to which graph we think goes with it below. EQ is how does the graph of y equals ax squared differ, or ax squared plus c differ from just ax squared. So how does that adding or subtracting c value change the graph? But before we get to that, let's take a look at these four equations and these four graphs. What we saw in the first half of 9.1 is that if your x squared has a negative number in front of it, that's going to make the shape of the graph be a parabola that opens down. Okay, so right away, these first two equations I know have to go with this graph and that graph. Those are the two parabolas that open down. So now we have to decide which one is which. And what we also saw, besides the fact that a negative number makes the parabola open down, is that the further away from zero that the number is, the more narrow or skinny the parabola gets, and the closer to zero, the parabola flattens out and gets wider and wider. So with those two pieces of information, I can deduce that 0.5x squared or negative 0.5x squared goes with the green graph, and negative 3x squared, because 3 is further away from 0, it's going to make that graph be much more narrow and much closer together as far as like side to side goes. And then our two remaining graphs are the positive x squared graphs. I have 1.75, which is a little bit further away from 0 than this one. One thing I didn't explicitly state is if you see something like this, that's y equals x squared, the a value is 1. Just like normally if you don't see a number in front of a variable, you can put a 1. Same rule applies here. So if I compare blue graph to red graph, these two remaining parabolas, the blue one here is a little bit narrower than the red one. So that tells me that 1.75x squared is going to go with blue graph, and 1x squared is going to go with red graph. Okay, so that's kind of a quick summary of what we did in 9.1.1, where we introduced a parabola and saw how the a value affects the shape of a graph. And what we said was if a is positive, then the graph is going to open up, which means the vertex, and remember the vertex is the point at either the top or the bottom of the parabola. So here the vertex would be a minimum. I'm just going to say min for now. If the a value is negative, if a is negative for a parabola, then I'm going to have a parabola that opens down, and the vertex would be up top. You don't need to put like the plus plus and the minus minus. It's just something that I was shown as a student. So, and I've remembered it ever since. And then what happens to the parabola as a gets closer to 0? As a gets closer to 0, the parabola flattens or widens. So it looks something like this. That would be an example of a parabola that has an a value that's really close to 0. Okay, so what we're going to take a look at today is here we have a graph here we have the equation y equals 2x squared minus 3. So we know the fact that the first number is 2 tells us it's positive 2, so the graph's going to open up, and the number is bigger than 1, so the graph's going to be a little bit narrower than our standard parabola. But what we're going to take a look at and what we want to focus on today is what does that -3 do to the graph? So in Desmos, I already have, here I have 2x squared in red. You can see here's the parabola, comes down, vertex at 0, 0, and then it goes back up. If I put the -3 on it, that's the blue graph. So also comes down, vertex down here, and then goes back up. Now, what is visually misleading is that it looks like the blue graph is bigger or wider than the red graph, and that's not true. These are actually the exact same shape graph. All that happened is that the red graph was pulled down to meet the blue graph, or to make the blue graph. And if you see this -3, the vertex now, instead of being at 0, 0 like we're used to seeing or that we saw in the previous video, now the vertex is down here at 0, -3. So what that -3 does is it just basically picks up the entire parabola, moves everything down 3 units, and then it puts it down right there. So we have one coordinate for the graph, but if we want to actually graph this, it's tough to recreate a graph that looks like this on your own paper, or if you were graphing on your own. So I'm going to show you real quick how to use the graphing calculator, which is available if you don't have your own. We have a digital version of it for free that's available for you to use. That's in Schoology, or a link for it's in Schoology. So over here on the calculator, I'm going to hit the y equals button. If there's something in there, I'm going to clear it out, and then I'm going to go ahead and type this equation that was given, 2x squared minus, make sure you hit the minus sign, not the negative sign, -3. Now, if I hit graph, I'll see the same picture, actually in the same color, luckily, that we see here. Okay, so it goes down, vertex at 0, -3, goes back up. But that doesn't really help me, again, if I wanted to graph that, because all I know is that one point. So what we're going to do is above the graph button, it says table in blue. So if you hit the second button and then hit graph, it will give you a list of coordinates that are on this parabola. Now, I don't want to graph 10, 197 because my graph isn't that large. So most of the time, standard graphing parabolas is going to go from -2 to +2. So we get a little bit of the negative side and a little bit of the positive side. So here I see -2 goes with 5. -1 goes with -1. 0 goes with -3, which we already knew from Desmos. And then 1 goes with -1. 2 goes with -5. What's kind of cool here, and I don't want to spend a ton of time on this, but these values will repeat themselves as you move away from the vertex. Okay, so if you don't see some sort of pattern, it means you're either doing something wrong or the vertex isn't included in your table. So I'm going to go ahead and graph these 5 points. So -2, 1, 2, 3, 4, 5 is right there. -1, -1 is right there. 0, -3. 1, -1, and 2, 1, 2, 3, 4, 5. Okay, so if I connect these points, some interesting things happen. It still opens up. Okay, the graph opens up, and we knew that. The vertex is now down here. The vertex is a minimum, but the vertex is not 0, 0. It's 0, -3. Even though the vertex moved, the line of symmetry, which I've mentioned sparingly, the line of symmetry hasn't changed. The line of symmetry, if I wanted to split this parabola in half, would still be straight down the y-axis here, because then the parabola would fold in on itself perfectly. So basically what adding or subtracting the 3 does is it just moves the graph down. If I go to Desmos, I just want to show you this quick, and if I put in +c, if c starts out at 0, you'll see that the vertex is at 0, 0. And as I move the c value up, the entire graph is just moving up. As c value goes to 0 and then to the negative, the entire graph is moving down. Okay, so all that's happening is it's truly just sliding the graph. It's called a translation. It's just sliding the graph up and down. Okay, and whatever number I land on for a c value is going to be the y coordinate for the vertex. Okay, so there's a really interesting comparison there. If c is 2.7, then hey, look at our vertex is 0, 2.7. Okay, so that plus c, just understanding that it moves up and down. If you have your own calculator, go ahead, pause the video now. I want you to try typing this equation in and using the table function to get the values and then graphing what you get from there. So in order to graph this, I'm going to, again, go to hit the y equals button, which is the upper left-hand button on your calculator. Clear this out. I'm going to go negative. So here, because it's leading with a negative, I do have to use the negative button. I can do -1 or just the negative sign. X squared plus 5. I think the dogs want to go to bed. I get a preview of the graph, so it's going to look like that. So you can see it's been moved up 5 because the vertex is up here, and then it's opening down. I'm going to go to the table. -2 goes with +1, and then +4, and then 5, and then 4, and then 1. So -2, 1, -1, 4. Oh boy. All right. So those are my 5 points. I'm going to go ahead and connect them. You can see that the parabola opens down because the front number is negative, but because my a value is -1, it actually didn't make the graph wider or narrower than normal. This is your standard parabola width. It just happens to open down instead, and it was moved up 5 units. So that's how you can graph these equations. Calculator is super helpful. If you are having trouble with accessing the calculator, please contact your teacher because it's a tool that can really save you a lot of time. So how does the c value affect the shape of the parabola? My goodness, shape does not change. This is super important. The graph isn't getting wider or narrower. All that's happening is the parabola is sliding up and down. The c value slides graph up or down. So if you had y equals x squared plus 2, this is up 2. Y equals x squared minus 4. Because it's minus, that would be going down 4. Okay. Vertex moves. The line of symmetry does not. I'm going to use LOS for line of symmetry. Okay. So that's how the c value changes the shape of the graph. So let's take a look at and see how much information we can deduce for what a graph is going to look like without even actually graphing it. Okay, so if we said y equals 3x squared minus 4, and I asked you, where's the vertex of that parabola going to be? We know that the a value does not affect the vertex at all, but that -4 brings the entire graph down 4. So the vertex is going to be at 0, -4. Okay. Opens up or down. I'm always just looking at the a value, and the number doesn't even matter. Is it positive or negative? And because it's a +3, I'm going to say this graph opens up. And because it opens up, the vertex is going to be at the bottom of the graph, right? If I have a vertex or a parabola that goes like that, the vertex is at the bottom. So the vertex is a minimum. If you want to try the next two on your own, go for it. But here I have -0.5x squared minus 2. So the -2 is going to bring me down 2. So that's my y coordinate of my parabola. Or sorry, the y coordinate of my vertex of the parabola. The a value is -0.5. And the 0.5, again, doesn't matter. It's the fact that it opens down. Since it opens down, that means my vertex is a maximum. And then finally, one more time, x squared plus 8 means the vertex is moved all the way up to 0, 8. It is positive x squared. The a value is 1. if you want, you can put the 1 in there, which means the graph opens up. And because the graph opens up, then the vertex is a minimum. Okay, so there's a lot of information we can pull about a parabola without even graphing it. So, summary: how does the graph of y equal ax squared plus c differ from y equals ax squared? I mean, really, I'm just putting what was on here earlier. C value slides the graph and the vertex up or down. Y equals x squared plus 3 means that goes up 3. Y equals x squared minus 5. This means that goes down. Oh my goodness. Last two letters couldn't do it. Down 5. There it is.